3 pi over 2 I'm trying to write. Pi over 2, 2 pi over 2, 3 pi over 2, right? And that's 18 pi over 12? Yes, it is. So if I have one more pi over 12, I can call that 19 pi over 12. So I could say that. But 4x could be either 5 pi over 12 or 19 pi over 12. But what's perhaps a simpler way of describing that? All right, so this angle here is 5 pi over 12. What's this angle here? Well, you might say also 5 pi over 12, right? But it's negative because it's clockwise, right? So if we're going to give this a sign, we'd say this is negative 5 pi over 12. And so that says, 4x would be either positive or negative 5 pi over 12. You could say, 5 pi over 12 or 19 pi over 12, but 19 pi over 12 is negative 5 pi over 12 plus 2 pi. Right? 2 pi being 24 pi over 12. So, or any angle coterminal with those two, right? So you see the different symmetry here. Here I need to be talking about y-axis symmetry, so I'm talking about supplements. Here I'm talking about x-axis symmetry, not this x, right? So with that I can say, clockwise or counterclockwise, right? Even function, odd function. So I can write it on one line instead of writing it on 2 lines like I did here. I can just say plus or minus 5 pi over 12, or any angle coterminal with one of those. All right, so then when I solve for x, I'm going to have plus or minus 5 pi over 48, right? Plus any multiple of pi k pi over 2, right? Reducing by a factor of 2. So where are those angles? And so I guess you could say here they are, right? So I found all solutions where again k is in the set of integers, right? That's a k. Right. How about oftentimes what they do is they say, you got infinitely many solutions, but there is a finite number of places on the unit circle, right? So what are those places? And can we say, find all values in the interval from 0 to 2 pi, say, right? Okay, so for that, I would start with, if k is 0, I've got one, right? So it's going to be 5 pi over 48. Where's that? Oh, I don't know. 5 pi over 12 is here. If I cut that in half and then cut it in half again, I'm going to have 1/4 of that, which would be 5 pi over 28, which 48, which I think is going to be like here, a little bit bigger than pi over 12. Right? I'm saying this is 1/4 of that. It's going to be about here. Right? So what's another place? Well, I want, so if I apply the negative here, I'm not going to get a number between, so this is k equals 0 here, right? But I only get one positive result, k equals 0. How about k equals 1? K equals 1, then I'm going to add common denominator, huh? So that's going to be like 24 pi over 48. Pi over 2 is 24 pi over 48. So if I add 24 to that, I'm going to get 29 pi over 48. That's a lot of pi over 48. But it's still less than 2 pi, right? 96 pi over 48 would be 2 pi. So we're not at 2 pi, we're between 0 and 2 pi. And so this is k equals 1 if we add to the positive 1. What if we add to the negative 1? Well, then we're going to have 24 pi over 48 minus 5 pi is 19 pi over 48. These are not necessarily in order, I guess, right? But that will be two different positive values for k equals 1, right? How about k equals 2? Can we get k equals 2? That would be pi. Pi is 48 pi over 48. So 48 pi plus 5 is 53 pi. 48. This is k equals 2 now. And if I add to the negative, I'm going to have 48 pi over 48 minus 5 pi over 48. That'll be 43. You start to see the patterns in here, right? So what are the patterns? Well, let's start with 5 pi, add 24, add 24 again, right? So keep adding 24 pi to the numerator, and then start with 19 pi and add 24 to that, right? So I can just sort of continue on in that fashion, right? So if I add 24 to this, I'm going to get 77, right? 77 pi over 48. And if I add 24 to that, I'm going to get 67 pi over 40. Notice that they're differing by 10 pi over 48, right? So that's another pattern you can see in here. This is for k equals 3. Are we outside the interval yet? No. 96 pi over 48 is still bigger than any of these. So, but if I add another, what is it? We're adding 24. If I add 24 to the 77, I'm going to get too big, right? However, if I add 24 to 67, I'm going to get 91. So this is if k equals 4, and I have the negative 1 to start out with. So you notice there's only 1 for k equals 0, and there's only 1 for k equals 4. There's 2 for k equals 1, 2 for k equals 2, 2 for k equals 3, and that gives me a total of 8, right? 8 different places on the circle where this equation is true, and then all points coterminal with those 8. That's kind of what you have to do for multiple angles, right? But let's then take up with the book in section. I don't know, where are we?
I think you were doing 7.4.
7.4. Look, it's a big, heavy thing. Unless you got the loose leaf version, you just take what you need, right? Leave the rest. So 7.4. So any questions from the exercises in there? Yeah. You can just work some at random. How about something where they give you a which one?
So is it always going to be from 0 to 2 pi?
Yeah, I mean, if you're talking about all the different places, all the places will go. There was a talk on that today. I missed that. So, something about chemistry.
Oh, the chemistry.
Did you get that? I missed it. Nobody went, huh? I should have given you extra credit.
It was
that
about
lecture series for chemistry?
Yeah.
Yeah, I think it was during Mason's
Ah.
Mason class.
he talked about bio weapons. It was pretty cool.
Uh-huh.
Anthrax and stuff like that.
Yeah. Or what was the latest one that supposedly the Russians were
Oh yeah.
doing something? Yeah. You know, when it comes to those clandestine agencies, I just, no, I don't believe anything. All right. Any questions about this before? So, okay, so let's go so this is kind of setting the state. It's kind of 7.4, but I don't know how many exercises there are like this in 7.4. Not a lot, right? In 7.4, we don't get multiple angles, we just get simple angles, right? But we do get some factoring situations. So, well, how about 42? Always a good choice. So 7.4, number 42. Here we've got something that's quadratic in sign. Theta minus sine theta, I forget. 42, huh? Yeah, minus 1.
Professor, quadratics. Do those normally happen in like life? That's for like finding a chunk of a square missing, right?
When you complete a square? You
Well,
think
the,
of it that way?
the
Yeah.
quadratics in general is pretty much. I mean, they just kind of describe just